Number 23, we are still factoring, but as you'll see, the answers look very, very different from what they did on the actual pure factoring section. Because right here, we're solving by factoring, meaning our final answer are points. Okay, our final answers are points. Specifically, there are roots, are zeros. They're where we cross the x-axis. That's what we want to know. We want to know, when does this trinomial quadratic equal a height of 0? And we always need this to be 0 first. So this is what I told you today, and I would remind you that you might want to write this on your scratch paper as soon as the test gets handed out, not before, but as soon as you get the test, you might want to write yourself a little reminder, get 0 first, okay? Get 0 first. Well, on 23, it's already done, but I don't want to forget the rule, so I wrote it down. 23, it's already done. 0 is by itself over here. That means we can take on this problem like a normal factoring problem from the start. I'm looking for factors of negative 5x squared that can add together to be 4x. Well, there's only two factors of 5, and that's 5x and 1x. I need to make one of them negative. Look, if I make that one negative, it makes this a negative 4x. That's not what I wanted. So it must be the other one, because I needed to make a negative 5 by multiplication. Now that I've done that, I'm ready to box everything up. I have x squared and negative 5, 5x and negative 1x. I'm just going to get an x out right there and just a 5 there, an x here, and a negative 1 here. Yeah, I'm going a little bit faster on the factoring, okay? This is a negative 1 because that's negative. It has nothing to do with that one. Please don't get caught up thinking they both have to be negative or something like that. Just matters about whatever one's next to it. So if I was just factoring, which is what I've done so far, I would finish up with x plus 5 and x minus 1. I'd be like, sweet, there's my answer, 5 and minus 1. And I'd probably get confused and circle something like this or like that, okay? Probably have a distractor on the actual test that's 5, 0 and negative 1, 0, stuff like that. But that's not the answer, because we're not done solving. This was actually all set equal to 0. So we have two things, two binomials with variables in them that we're not sure of yet. And these two binomials are multiplying to be a 0. It means one of them is going to be 0 or both of them have to be 0. So I need to find where they are 0. X plus 5 equals 0. X minus 1 equals 0. Minus 5 minus 5. This is our new stuff. We get x equals negative 5. That correlates to the point on the x-axis, negative 5, 0. Similarly, we're going to add 1 and add 1. I get x equals 1, meaning that point, that root, is 1, 0. I look through my answers. I see that it is A. One way to check these would be to graph them, but that will not always work. If I go into my graph, I can type in my original problem, which is x squared plus 4x minus 5, because that's when it's solved for 0 already. And I can look at the graph. I'm looking for it to cross at negative 5. 1, 2, 1, 2, 3, 4, negative 5, and positive 1. There is another way to do it, and it's actually a method that helps people out on a lot of math tests. If it's multiple choice, on somewhere near half the problems on a normal math test, not on this one has less of it, on about half of a math test problem, multiple choice problems, you can usually use the answers to your advantage. What do I mean by that? Well, if we're saying that x equals 1, we can plug a 1 in for x on the left side and see if we get a 0, which we should on the right side. So every time I plug in, I use parentheses. 1 squared plus 4 times 1 minus 5. That's if I plug a 1 in, because one of my answers was 1. Well, I do get 0. What was my other answer? Negative 5. Let's try plugging in negative 5 in. Negative 5 squared plus 4 times negative 5. Oh, there's no way this one's going to work. It's too many weird numbers. Minus 5. I press enter, and lo and behold, you get another 0. So please know, 3 ways to do it. The correct way, solve it by factoring. The backup method, graph it, but that will not always work. Not once we start getting into a bunch of fraction ones. And then the final method is knowing that you can plug them in, but you got to be a little bit calculator savvy for that. Number 24, we probably forget because I just erased it, but I had a step up here that says get 0 first up here at top. That's for problems like this. If you look up here and you say, oh my gosh, that's going to be some massive amount of factors that we're going to have to look through, blah, blah, blah. Pause and reevaluate. This 7's throwing everything off because this 127's throwing everything off. We need to get 0 first, meaning we need to add 7 to both sides. My new trinomial is 6n squared plus 6n minus 120 equals 0. That's standard form with a 0 on the right-hand side. Now we can factor. Speaking of factoring, we had a golden rule for factoring. And that golden rule was if you can, take out a GCF. 6 will come out of all 3 of these numbers. There's no variable that they all share. So we have 6 coming out front with an n squared being left behind. 6 divided by 6 is just 1n. And 6 into negative 20, or negative 120 is just 20. Now we're going to still factor this inside trinomial. What's inside here? We're looking for factors of negative 20n squared, factors of it, that's the little factor tree, that add together to be 1n. Sometimes I do like to write the 1 here to remind myself because I'm doing operations to try to get to it. If I go through the factors of 20, again, you can go through them in your head, you can go through them by writing them out. You can also go through by just dividing 20 by x. When I do that, I look at the table and I see all the factors of 20. When I get down to 4 and 5, I think, oh, 4 and 5 are really close together. In fact, they're only 1 apart. Well, now I have to make one of them a negative and one's got to be a positive because they still need to multiply to be negative 20. If I make this one negative, I've now multiplied to be negative 20 and I let the 5 win out and give me a positive 1n. So it's time to box everything up. Please be careful when boxing up the first and last term because we've had like 3 different trinomials here. We had our original trinomial that had a 6n squared, no, negative 127. We had our solved trinomial with a 120. But what we actually used to factor here was this inside trinomial with just an n squared and a negative 20. Why would you ever go back and use the hard one once you found a nice easy one? You wouldn't, okay? If someone teaches you how to do something the hard way and teaches you how to do it the easy way, if they do the same thing, you're going with the easy route. This is just an n. This is a negative 4 because that's negative. This is an n. The largest number we can take out of both of these is 5, okay? So I get n minus 4 and n plus 5. With a 6 out front, this all equals 0. So now you can say, Mr. Snow, we have 3 pieces now. What are we going to do? Well, the first one is 6 equals 0. The next one is n minus 4 equals 0. And the final one is n plus 5 equals 0. Sometimes this will have a variable on it, at which point your variable will equal 0. But is 6 ever going to equal 0? Does 6 equal 0? No, it does not. So that one doesn't matter. This is just a scalar. All that does is it shrinks or flattens out the quadratic. It doesn't actually change the zeros. We'll get to that whenever we get to properties. Here we're going to add 4 to both sides. We get that n equals 4, telling us one of our zeros is 4, 0. Next, we're going to subtract 5 from both sides. We get n equals negative 5, giving us the other 0 of negative 5, 0. So we're looking for 4 and negative 5. There's 4 and negative 5. Careful, that's a really good distractor there. Get you every time if you're just looking here and going, oh, negative 4, positive 5, done and done. I would strongly suggest checking these. Here's where you'll run into issues. You cannot check from this original problem. You have to check our solved one. So I pull it up. 6x squared plus 6x minus 120. And when we graph it, we are hoping to see zeros at 4 and negative 5. Negative 1, 2, 3, 4, negative 5, and positive 1, 2, 3, 4. We've done it correctly. Save the best for last. It's a tough problem. First, I need to go ahead and move the 3 over. Okay? When I move the 3 over, I subtract 3, subtract 3. This is going to be 7x squared minus 6x equals 0, because these are going to cancel, those are going to cancel. Next, I'm looking at this, I'm saying, wait, I'm supposed to solve this by factoring? Huh? Well, you know the factoring rules. If you can, take out a GCF. When that 3 went away, we only had 2 terms to worry about. X comes out front. 7x minus 6 gets left behind. So now, there's nothing else factoring out here. It's a binomial like we're used to seeing. Now it's just time to separate our problem. Well, our first piece is x. We set x equal to 0. And our next one is 7x minus 6 equals 0. This is exactly the situation I was just talking about. If x equals 0, that means my 0 is 0 equals 0, because it's already solved. Okay? That lets me know it's probably this answer, but I am going to check just to be careful. Plus 6 plus 6. Divide by 7, divide by 7. X equals 6/7. That gives us the 0 of 6/7, comma, 0. This is one of those ones that, yeah, you could say you check it in the calculator, but it's really hard to tell with 6/7 here. So when we solved it, remember we can't check the original, we got to check our solved answer. We have 7x squared minus 6x. I graph that. I see that it does indeed go through 0, 0, and then it looks like it goes through 1. So you might look there and be like, oh, maybe it's this one with the 1, 0. Okay, but if you were to zoom in, oops, that was zooming out. This may take a minute. Let's go back to our standard. If we were to zoom in, which is number 2, get a little bit closer, now you see it go through 0 and you see, oh, it actually misses 1 just by a hair. Well, that's what positive 6/7 is. It's just a little bit under 1. So again, you can check in the calculator, but checking these in the calculator is not an exact science. Okay, it's more of an estimate. So I would make sure that I could do them by hand.